Organizers. Welcome to your Chapter 6, Lesson 2 notes. We are going to look at scenarios where there's only an x squared and a number. So the middle x term isn't there, so I don't need to handle this by factoring. I can get just the x squared alone set equal to a number on the other side and take the square root of both sides. So this is nice. These will specifically be no middle x term present. So they will not look like ax squared plus bx plus c equals 0, like our typical standard form of a quadratic equation. No, they're not going to have the b term. Okay, so b is not going to be present. They're going to look like ax squared plus c equals 0 or ax squared equals c. One of those two scenarios is how these will look. Now, they're going to be great when they look like x squared equals 81 because your x squared is already alone. So all you have to do is take the square root of both sides, like in the example here. What you need to remember, and this is going to be the key through this whole part of the chapter, is when you take the square root of both sides yourself, a plus and minus is automatically there because there's both a positive and a negative when you take the square root of something yourself. So that even includes if there's a negative number under the radical, that there's a plus and minus in front of the radical. Okay, that's one of the keys you need to remember. When you take the square root of both sides yourself, there's going to be a plus and minus as part of the answer. Okay, so now what we're looking at is, so not all of these answers will be integers. Well, that's okay. We're used to that. And not all of these answers will be real numbers. Okay, we're used to that. We've covered both, so we'll be good. All right? So I think we should just begin and look at some examples. Okay? Oh, look at that. It's so important. I wrote it in the notes too. All your solution sets will have a plus and minus. Okay, so, one of the easy ones, right? X squared already alone, something on the other side of the equal sign, take the square root of both sides. Done and done. Here I go. Well, the square root of x squared is x. But what did I just say we had to remember? Took the square root of the other side, so plus and minus needs to come in front. Square root of 1 is 1. There's my answer. B, you've got to get x squared alone first. So the opposite of a negative 25 is add 25 to both sides. Now notice in the last lesson, I would have factored that by dots. But actually with no middle term, I could just have x squared equals 25 and take the square root of both sides. Square root of x squared is x. The square root of 25 is plus and minus 5, and there's my answer. So get that x squared alone first. So that's what's going to be key right here. Get that x squared alone first. So add 27 to both sides first. 3x squared equals 27. Now divide both sides by 3. Get that x squared alone before you take the square root. Get that x squared alone before you take the square root. Now 27 divided by 3 is 9. Take the square root of both sides. Wow, we've been lucky that these have all been perfect squares. All of them. All of them have been perfect squares so far. It's almost like I planned it. I probably did. Makes sense. Seems a little easy so far, doesn't it? It's actually not that hard. We just need to remember that not everything will be a perfect square, right? So on the next page, that's when we will encounter things that are not perfect square integers. Looks to me like some of these guys will still be perfect squares. So like here, for example, got to get x squared alone first. So start by adding 9 to both sides. Okay, so I get 16x squared equals 9. So divide both sides by 16. I know that 9 doesn't evenly divide by 16, but I've got to get my x squared alone first. So I'm going to leave that as a fraction and then take the square root of both sides. So it doesn't have to be that the number on the other side can evenly divide by my denominator. But what is important is now that I'm taking the square root of both sides, I have to simplify that other side. So over here, of course, a plus and minus goes in front of whatever this is. Just so happens that 9 is a perfect square on top, 16 is a perfect square on the bottom. That means it's plus and minus 3/4 is my answer. And I just leave it that way. No need to turn it into a decimal. You don't have to. I mean, it is rational, but still, no need. Here, I'm shedding. It's winter, and I'm shedding, just like your animals at home, probably. All right, get that alone. Oh, man, it's going to be a negative. Oh, that means that when I take the square root, it's going to be an imaginary number. Darn. Well, it's all right. Chapter 5 was fun. We've used to working with those, right? 64 divided by 4, negative 16. Take the square root of both sides. We know how to deal with a negative under the radical now. So it's plus and minus. I'll do it this way to start so I can remind you. Negative radical 16, right? But the square root of negative 1 is I, and the square root of positive 16 is 4. So this is x equals plus and minus 4i. Just like that. Next. Move this 35 over. 5x squared plus 30 equals 35. Oh, it's positive, so that's okay. Divide by 5, x squared equals 7. Now take the square root of both sides. Oh, 7 is not a perfect square. Is it evenly divisible by a perfect square? No. Plus and minus radical 7 it is, both the positive and the negative. That's it. I did my best to try and simplify it. I couldn't get any further. That's okay. As long as you're trying, right? You simplify anything you can. Oh, that's right. This is my last page. Still going. Always get x squared alone. So notice that's the first thing I'm doing every time. Oh, this one's going to be an imaginary. Ooh, it's negative 7 over here. So I take the square root of both sides. Okay, so I can't leave a negative under the radical. That's an I, right? So that part comes out. But actually, I can't simplify positive radical 7 any further, right? So my final answer here is just plus and minus I radical 7. That's it. X squared already alone. Take the square root of both sides. Oh, no. Oh, no squared there. Sorry, I took the square root. It's gone. Now, I can take the square root of 1 on top there, and it is 1. But this radical 3 is on the bottom. And am I allowed to leave a radical in a denominator? No way. No way, Jose. Gotta rationalize, says chapter 4. So that's what I do. See, I'm just giving you all the scenarios that now go back and mean that you had to do chapter 4 and you had to do chapter 5 in order to get here. And so you can see why this is the first we're talking about this, because we had so much work we had to do to get here. 1 times radical 3 on top is radical 3 on top. On the bottom, any radical times itself means the radical has canceled and just the radicand is left. And now it's a rational answer. So plus and minus radical 3 over 3 is my final answer there. One more, and then you can practice on your own. And of course, this one more is going to be imaginary. Of course it is. Why wouldn't it be? Divide both sides by 35 because you got to get x squared alone. All this means is my denominator is where the 7 is. So now when I take the square root of both sides, I just got a lot of stuff I have to consider, okay? First of all, I've taken the square root of both sides. So that means the plus and minus goes in front. Second of all, this is a negative number under the radical. So an I is going to pop out. And I'll just do that right now, right? Square root of 1 is 1, but you've got a radical 7 on the bottom, and that's not allowed to stay on the bottom. So multiply top and bottom by radical 7 to rationalize. X equals plus and minus I radical 7. When they multiply together, that's what we get, over 7. That is the best we got. because this is a not in a radical. So these guys cannot simplify any further. Not in a radical. This guy's not in a radical. Can't do it. So your final answer there, plus and minus, I radical 7 over 7. Perfect timing, because that's me starting 8th mod right now. And there we go. I'll zoom out. Lots of examples. Lots of examples. You're going to encounter all of these types of examples on your homework, so please practice this. It does go back through the stuff we learned in chapter 4 and the stuff we learned in chapter 5. That's why we had to learn all about radicals and complex numbers before we could really get into solving quadratic equations. Because now that we're in Algebra 2, we understand that solving quadratic equations means that our answers probably won't be integers. Okay? Alrighty, guys. This has been Chapter 6, Lesson 2 notes. Good luck. I am sure you will do wonderfully, but don't forget, when you are taking the square root of both sides, you put that plus and minus in front of the answer. That is going to be important in all of our subsequent lessons at this beginning of Chapter 6. All right, guys. Have fun with it. I'll see ya. Bye.